I'm thinking we could go ahead and actually get started on this because I want to remind everybody about a trick that we used on week 1. We're kind of getting to the part of the book where the things we've been practicing are kind of building up on each other. So good morning. So thinking back to our lovely fun with fractions at the beginning of the quarter, if we have fractions, 1, we're not going to panic. 2, I'm going to look for an equal sign. And if I have fractions and an equal sign, I don't need to worry about getting a common denominator. If I have fractions and an equal sign, personally, I'm going to choose to get rid of the denominators. That isn't the only option you have. So if you did it a different way, don't like erase what you have. Let's just see if we get the same answer in the end. But for me, I'm going to look at this and say, gosh, I've got a 5 and a 4 as denominators. I'm going to take both sides of my equation and multiply by that 4 and that 5. Now you could write that as multiplying by 20. I'm doing it as times 4 and times 5, just so that when I distribute it out, it's easier to find those ones. So if I take the 4 and the 5 and I distribute it over here, I'll have 4 times 5 times x all over 5 plus 4 times 5 times 2. On the right-hand side, when I distribute the 4 times 5 in, I'll have 3x times 4 times 5 minus 1 times 4 times 5 all over 4. Now, the whole point of multiplying both sides by the common denominator is so that my 5 over 5s will go away and my 4 over 4 will go away, and suddenly I have no more fractions. It's not the only option, but if I've got fractions and an equal sign, it is definitely the path I'm going to take. So if I collect things together now, I've got 4x. When I do this multiplication, 5 times 2 is 10, times 4, I'm going to get 40. 4 times 5 is 20, times 3 will make that a 60. So I've got 60x, and then minus 5. Doesn't really matter which side I put my x's on. I personally tend to put them on the side that'll make the coefficient positive. That's just habit for me. So I'm going to add 5 to both sides, and I'm also going to subtract 4x from both sides. And when I do that, I'm going to end up with 45 is equal to 56x, or x is equal to 45 over 56. Now we could pause here for a second and say, oh, I wonder if that's in lowest terms. So if I wanted to check to see if 45 over 56 was in lowest terms, I'm going to bring in another skill from that first section of the book. And I'm going to think about the prime factorization for both of those numbers. So if I take that 45, I know that 45 is 5 times 9. And that 9 is a 3 times 3. And 56, I don't know, at least it's divisible by 2. That's 2 times 28. And then 28 is 4 times 7. And 4 is 2 times 2. But it looks like those don't have any common factors, which means this actually already is in lowest terms. I'm pausing here just for a second in case there are questions on this one. And then I did have a request to work through one of the homework problems. So I am pulling that up right now. Not seeing any questions in the chat. Not seeing any questions in the room. So let's take a look at chapter 6 homework. And question number 3. Oh, question about this. Yeah. This stuff, I want to say, this is chapter 2, kind of, and kind of a little bit of chapter 1 stuff. But if you are looking in Canvas, you probably want to take a look at the fractions packet. Which talks about when do we need a common denominator and when do we not? When do we have to get a common denominator and when do we get to eliminate the denominators? And it looks like there's a request in the chat to do another similar problem and like talk through the approach, which we will definitely do. But I want to address, you said question 3 from the homework? Okay, so let's take a look at question 3 from the homework, and I'm happy to do any other problems from the homework as well. But this is the chapter 6 homework, number 3. Okay. And my guess is that most of the grossness is about the gross factoring we're about to do. So I've got xy minus 2x plus 3y minus 6 all over y cubed minus 2y squared minus y plus 2. Okay. And the instructions here are just to reduce to lowest terms. Well, in general, that reduced to lowest terms thing means that we're going to have to factor. So if we're talking about fractions and numbers, we're talking about that prime factorization piece. That's definitely in chapter 1. If we're talking about anything other than numbers, we're going to use our various factoring techniques, meaning factoring out the greatest common factor. If it's a trinomial, we've got that X method, or just kind of guessing at our factors. And if it's anything else, I check if it's a special factoring thing. Way too many terms here for either of those to be special factoring. So we're hoping they factor by grouping. So let's take a look at the top first. And by default, I'm just going to group the first 2 terms and the second 2 terms together and hope it's enough. So if I group the first 2 terms together on top, they have an X in common. And when I factor that X out, I'm left with a Y minus 2. The whole point of factoring by grouping is that we hope that that Y minus 2 appears in the second group as well. And I think it will if we factor a 3 out. Now we can turn our attention to the denominator. And in the denominator, I group those first 2 terms and the second 2 terms. From my first 2 terms, I can pull out a y squared. And when I do that, I'm left with a y minus 2. Because I want a y minus 2 to appear from the second grouping, the only way that's going to happen is if I factor out a -1. And the whole idea with factoring is it's sort of undoing the multiplication. So I'm thinking backwards in my head, distributing in that negative one times what is going to give me the negative y, and that would be a positive y. Negative 1 times what would give me positive 2, and that's going to be negative 2. Because I have addition and subtraction, addition in the top, subtraction in the bottom, I can't just cancel those y minus 2's out right now. The net result is going to be the same, but we need to take a minute to make sure that we have everything on top as multiplication and everything on the bottom as multiplication also. Which means on the top, I'm going to finish my factoring and get x plus 3 times y minus 2. And on the bottom, when I finish my factoring, I've got y squared minus 1 times y minus 2. And now that I have multiplication, now that y minus 2 over y minus 2 will be a 1. I would say it is fine to leave this as x plus 3 over y squared minus 1, or to write that as a y minus 1, y plus 1, just to have practiced our factoring a little more. And there is a request to take a look at problem 6 on the homework as well. So I'm happy to do that, but I'll pause here in case there were questions about that. I am not seeing questions on that. Okay. So sure, let's take a look at question 6 on the homework. Lots of factoring, and I'm going to do the factoring part quickly on problem 6. Just, it is something that you're going to need to practice. But number 6, I've got x squared plus x minus 6 over x squared plus 4x plus 3. Now in the book, it's written with the division symbol. I'm going to save myself the time and actually just go ahead and write that as times and flip it over. Now I did get a question by email that I thought was worth talking to everybody about. If the question, I was talking about restrictions on the variable the other day. If the question doesn't explicitly ask you to state the restrictions on the variable, you can go ahead and skip that step. Or yeah. With the exception that for any of the problems where you're solving for x, you have to take into account the restriction. And so if it asks you to solve for x, even if it does not explicitly tell you to state the restriction, you're going to need to state the restriction to make sure that you don't end up with bad solutions. Okay, so here we go. Says multiply or divide as indicated. Do not multiply this out. Factor everything. Get things in lowest terms. That's really what the instructions are telling us to do, even if they didn't explicitly state that. So I'm going to get my factoring going. So on the top, I need 2 things that multiply to give me -6, add to give me a +1. I'm looking at x plus 3 times x minus 2. On the bottom, I need 2 things that multiply to give me +3, add to give me +4. That's a +3 and a +1. On the bottom over here, I need 2 things that multiply to give me -8 and add up to +2. That's an x plus 4 and an x minus 2. By the way, if anyone is wondering how I'm doing these so quickly, the truth is there aren't that many factoring problems. If you do 100 factoring practice problems, you're probably going to start to see the same pairings of numbers show up over and over again. You're multiplying two things that add up to this other number. There's a finite set of things that you're going to multiply and add to this other number. Then I encounter the ones with the coefficient on the x squared not being 1, and it always slows me down. But I'm still going to do this fairly quickly. I know that has to be a 2x and an x. And I really have only two choices for that -3. Right? It's either 3 and 1 or 1 and 3. That's it. It's going to have to be a 3 and a 1. I'm going to need my 3 to be negative and my 1 to be positive to end up with a negative there. Now, I'm going to take a minute to regroup things. Just, maybe I won't even worry about it. But I'm now looking, now that everything is multiplication, I'm looking for things that equal 1. X plus 3 over x plus 3, there's a 1. X plus 1 on the top and an x plus 1 on the bottom, there's another 1. X minus 2 on the top, x minus 2 on the bottom, there's another 1. Which means when all is said and done, the only thing I'm left with on top is 2x minus 3. And the only thing I'm left on the bottom is x plus 4. Yay. So I kind of want to move on, though if people have more questions specifically they want to go over in the homework, I'll just kind of keep note of them, and as we have time, we can go back through them. Yeah.
So for the restrictions.
Yep.
How do you know
Writing what they are.
Yeah.
So, I will be here for the next few problems. I'll write the restrictions just so we have some practice at it. Okay. Just like fraction reminders. I know it's everybody's favorite, fun with fractions, right? Just to recap and refresh our memory, if I'm adding or subtracting, we need a common denominator. If we multiply or divide, in general, we should look for factors that cancel out to give us 1. So we should think about reducing to lowest terms. But if we're solving something, meaning we have an equal sign, then I like to eliminate the fractions. Now, these 3 rules hold whether our fractions are numbers or our fractions are variables. So we just did a problem where we were multiplying 2 fractions. And when I'm multiplying 2 fractions, I'm aiming to reduce to lowest terms. If I add 2 fractions, like, I'm going to keep this fairly simple. I'm going to do all the factoring for us today. So if I add 5 over x minus 2 plus 3x over x plus 1. And there is no equal sign in this problem. I'm going to need to get a common denominator. Now, sometimes it's harder to see when I've got letters in there than when I had numbers, but my common denominator is going to work the same way. One common denominator is always just multiplying the denominators together. So that I don't change the problem, when I get a common denominator, I have to multiply both terms by 1. 1 is the only number that I can multiply things by and not change the problem. Over here, my 1 is going to come in the form of x minus 2 over x minus 2. And over here, my 1 will come in the form of x plus 1 over x plus 1. The whole point of getting a common denominator is so that I can put this into a single fraction. And my single fraction is going to have a denominator of x minus 2 times x plus 1. On the top, I'm going to have to distribute things out. So I've got that x plus 1 times 5. So I'll distribute my 5 through and have 5x plus 5. And over here, 3x times x is going to give me plus 3x squared. And 3x times negative 2 would be minus 6x. I'm going to go ahead and recollect everything on top and say that that says 3x squared. I'm combining like terms, 5x and negative 6x would give me minus an x and then plus 5 all over x minus 2 times x plus 1. Now we could check and see if the top factors. And if the top did factor, then we would hope to reduce this to lowest terms. I am going to let everybody in on a little secret. It's actually something I don't know. I think I knew it, but then I actually learned more about it in graduate school. Maybe some people already know this trick. I'm gonna show it to you on a different problem. We already know what the factors of x squared minus 1 are. I kind of made it easy. So x minus 1 times x plus 1. If you think that something might be a factor, if it's a factor, then when you plug that number in, you should get 0. Here's what I mean. If you had a guess that x minus 1 was one of the factors of this, if x minus 1 is a factor, then what makes that x minus 1 equal to 0 is if x is equal to 1. And when you plug 1 into the original equation, you should get 0. You don't have to use this. I'm just throwing it out there. If this is not in the most reduced form, then when I plug in 2 to the top, or when I plug in negative 1 to the top, I should get 0. If I don't, then this was already in the most reduced form. This is just like a fun party trick. So I'm setting the entire factor equal to 0. right? So, and that's the same as what my restrictions on the variable would be here, right? So if I think about what the restriction is, I need the x minus 2 can't be 0 and the x plus 1 can't be 0, which would mean that's a -1 and that's a +2. And if I wanted to check if this thing was in its most reduced form, I would take the 2 and plug it in on top and see if I get 0. Well, if I plug 2 in, 2 squared is 4, that's a 12, minus a 2 plus it's definitely not 0. Yeah. We're gonna call it the domain. Yeah. So technically, at the moment, because this isn't a function, we don't use the phrasing of domain. As soon as we're talking about it as a function, then we switch our phrasing to be the domain. Yeah, totally. So when we're talking about expressions without like the context of a function or a graph or something, yeah, totally. If I plug in -1, -1 squared is +1, which would make that 3 minus a -1. So now I'm at +4 plus 5. Yeah. So neither of these give me a 0 on top when I plug them in. So I know that this is in lowest terms. You don't have to do that extra part. I'm just sharing it with you because sometimes it's a useful tool later on in life. So there's a question in the chat that probably could be helped by me drawing some things in. So when I got to this point, I distributed things out. And that is where my -6x term came from the 3x times -2. Question.
So, but when you plug them in,
Mhm.
like, let's say if like one of the restrictions gives you maybe 0, and the other one doesn't give you 0.
Yeah.
Is that possible, or is like?
Yeah, totally. And that's what I would expect. I would expect one of them to give us 0, but not both, right? Yeah. And if we had plugged in the 2 and it gave us a 0, then I know the top factors. That's all this trick is telling me. Again, you don't have to use this trick, but let me, just for the sake of argument, give us another one to illustrate weirdness. Okay. So let's say that we did this thing and, oh, I'm going to make the top kind of gross. Okay. Let's say that I needed to reduce this to lowest terms. Which would you rather factor right now, the top or the bottom? Bottom? Okay, how does the bottom factor? Okay, I need a 2 and a 1. And let's see, my 1's got to be -+2. Yeah, sounds good. Great. So I'm going to pause for a second and say, cool. What makes the denominator 0? Which two values of x, if I tried to plug them in, would make the bottom 0? Yep. So before I spend time factoring the top, I'm going to figure out if either of those make the top 0. Because if they do, then I know that's the factor. So if I plug in -2, -2 squared is 4, 4 times 12, I'm at 28, plus 14 minus, I'm like, no way, that's 0. If I plug in the 1, 12 times 1, I'm at 12, minus 7, so I'm at 5, minus 5, I get 0. Since plugging in the 1 gave me 0, I know that on top, one of my factors is that same factor that gave me the 0 on the bottom. That ought to make it a whole lot easier to factor this thing. Because I've got to get a 12x squared, so that needs to be a 12x. And I have to get a -5, so that has to be a +5. There aren't a ton of instances where that is helpful, but it can be really helpful. So I just wanted to give everybody that tool to add to your toolkit. By the way, that means that the x minus 1 over x minus 1 can reduce out, and I'm left with 12x plus 5 over x plus 2. But both of these are still restrictions on my variable. Because I want to keep the restrictions from the original problem, not just after I've reduced it. Question. So I got the 12x plus 5 because once I know that x minus 1 is one of the factors, I'm just thinking about what would I have to multiply the x by to get 12x squared? It has to be 12x. What am I going to multiply the -1 by to get -5? It has to be +5. You can check. That should be a -12x and a +5x, which should give me the -7x back. Good times? Dun, dun, dun. Okay. Let's just straight up solve for x on one of these. I'm gonna have 4 over x minus 2 plus 3 over x plus 1 is equal to 5 over x minus 2. Okay. We have fractions, but we also have an equal sign. So I know that if I need to solve this, I do not have to get a common denominator. I can eliminate the fractions instead. Before I do, because I have variables in those denominators, this is a case where I need to pause and state the restriction on the domain. So our restriction here is going to be that x cannot equal 2 and that x cannot be equal to -1. So if I finish this problem and get either of those as answers, it wasn't really an answer. Because in the original problem, if I plug in 2, I'm dividing by 0. And if I plug in -1, I'm dividing by 0. Now I'm ready to look at that and say, because of the equal sign, I'm going to multiply everything by the common denominator. And that common denominator is going to be the x minus 2 times x plus 1. I need both of those factors. On the right hand, I'll start on the left hand side. So on the left hand side, I need to distribute that in. So for the first part, I'm going to have x minus 2 times x plus 1 times 4. And that's over x minus 2. For the next part, I'm going to have x minus 2 times x plus 1 times 3. And that whole thing is over x plus 1. And on the right-hand side, I'll have 5 times x minus 2 times x plus 1, all over x minus 2. Now, it doesn't look like we got rid of the fractions yet, but that's because I haven't found my multiplications by 1. Well, on the first part, x minus 2 over x minus 2, that's a 1. On the second piece, x plus 1 over x plus 1, that's another 1. And on my last piece, x minus 2 over x minus 2 is another 1. So I'm left with x plus 1 times 4 plus x minus 2 times 3 is equal to 5 times x plus 1. And I will give everybody a minute to turn that into x equals some number. I fully anticipate it's probably gonna get a fraction, but I don't know. I just made a problem. Usually when I just make stuff up, the fractions. Don't know. Did it work out nice? No fractions? I have no idea. There is a fraction. Yeah. So it's okay, distributing stuff out, all your distributing stuff looks good. Oh, but you got 7x minus 5x and then, oh my God. Yeah. So if I distribute the stuff out here, I've got 4x plus 4 plus 3x minus 6 and 5x plus 5. If I put my like terms together on the left-hand side, 4x and 3x is going to leave me with a 7x. A positive 4 and a negative 6 would be a minus 2. And then I've got 5x plus 5. I would subtract the 5x from both sides and add the 2 to both sides. So I think I get 7/2 for a final answer. Quick reality check, that is not either of our restrictions. So we're good. That is actually our answer. Ta-da, we're done. Yeah.
Okay, so when you multiply the x times 2x plus 1,
Yeah.
you're not like to the
So there's a real subtle difference here of what's happening when I'm getting rid of denominators versus finding a common denominator. And I'll go back to like kind of what this looks like with numbers first. So if I had 2/5 plus 7/3, I have no equal sign. I'm trying to do addition of fractions. I have to get a common denominator. When I get a common denominator, this is when I'm multiplying by 1, which means that we can think about it as, like you said, kind of distributing that value to both the numerator and the denominator. If I had a different problem that looked like 2x plus 5, 2x over 5 plus 7/3 is equal to 4. Now I'm not getting a common denominator. I'm multiplying both sides of the equation by something. Both of those are keeping my problem the same, right? So in this case, I'm multiplying by 1, which doesn't change something. If I have an equal sign and I multiply both sides of the equation by the same number, I also am keeping it the same. So in this case, I'm multiplying the numerators by 5 times 3, but I'm doing it on both sides of the equation. So the same sort of thing is happening here. I'm multiplying the numerators on both sides of the equation by those factors. So I'm keeping the overall equation the same because I'm doing the same thing to both sides. That's the subtle difference there. Yeah. I've got about 3 minutes left. Are there other questions from the homework that anyone wants to go over? And in case you missed it the other day, you are welcome to do 14 and 15, but you definitely don't need to because nobody is calculating how long it's going to take to empty that pool, and no one cares what the speed of your boat is. Like really. Now, questions 16 and 17, which are about like mixing solutions of alcohol and talking about defective parts. Both of those are actually problems that will continue to show up in your life, either in a chemistry or biology or stats class, right? There are other places where those things are gonna show up. No one asked me about 18 or 19 on the homework, but they're kind of gross. So I thought if you wanted, we could take a look at one of those. And I know I'm almost out of time, so we might not actually get to finish this one, but this is a case where writing big is helpful. We've been asked to reduce this to lowest terms. And I'm looking at division and going, oh, we can definitely switch division to be multiplied by the reciprocal. The problem is, in order to do that, I need a single fraction on the bottom. And right now I don't have a single fraction. So for this one, we actually have to do this in 2 steps. We need common denominators. Then we can flip and multiply. Or we can look for the overall common denominator in the whole thing and multiply the top and the bottom by that. And I don't have a ton of time, so I'm going with this second option, but it's totally fine to do this. If I look overall at the problem, X is the common denominator. So if I take the entire top and multiply by X, and I take the entire bottom and multiply by X, I get to eliminate the denominators completely. So on top, when I distribute the X in, X times 1 is X. And when I distribute to the 2 over X, I'm just left with 2 because those X's cancel out. When I distribute on the bottom, X times 1 is X. When I distribute here, I get a -2. It's kind of a neat trick. But I'm out of time. Thank you all for hanging out with me today.